land developers, real estate professionals, architects, planners, municipal staff, and many, if not most, civil engineers today think they can download site data from GIS or online maps like Google Earth to replace the need for a land surveyor. For the most part, few, if any, online sources are accurate, and most of the information is derived from aerial photography. That data is within 5 foot horizontally and 1/2 foot vertically. When we download GIS data from a city, if it's within 5 feet, we're surprised, as most seems to be within about 20-foot accuracy compared to the actual survey. And in some cases, we have seen data in the wrong location over 400 foot, and that's recently. In the 1980s, those selling cities on GIS told decision makers they could quickly trace their existing plats and build a city map affordably. Then later on, accurately locate the section corners and stretch the map. This is called rubber sheeting, as if by magic the tens of thousands of lines within that section would somehow be accurate by stretching it. These non-technical stakeholders actually believed it, bought into the premise that a large-scale digital map could eventually be made precise at a later date. All of the buildings shown on a GIS map came from an aerial picture, as if a person tracing or somehow automated technology could tell the difference between a building corner and the shadow of a building. When a developer asks us to do a neighborhood design from GIS, we warn them that if the data is wrong, which it's likely to be, we cannot guarantee the numbers, and it will likely have to redo the entire plan after the land is surveying, paying twice for our work. The land surveyor will identify all encumbrances, easements, encroachments, overlaps, which may adversely affect the value of the land. Much of this information is missed when downloading GIS or online mapping. A licensed wetland delineator is the only professional that can locate and flag the definition of a wetland. But without a surveyor tying those flags to the actual boundary, it's impossible to lay out a new development with precision. On a typical large tract of land, this process is time-consuming. Yet somehow, the entire country was quickly defined by the maps available in the National Wetland Directory. This is the wording in their disclaimer. The maps are prepared from an analysis of high-altitude imagery. Wetlands are defined based on vegetation, visible hydrology, and geography. A margin of error is inherent with the use of imagery. Thus, detailed on-the-ground inspection of a particular site may result in the revision of the wetland boundaries or classification established through the image analysis. In other words, take it with a grain of salt. But local politicians don't do that. They will likely hold the developer to task should they decide to purchase land encumbered by this likely vague data. There is a possibility that the wetland is either larger, smaller, or in some cases, maybe many, simply non-existent. Most city maps are created in ESRI, the leading software. Those with subdivisions that have beautiful winding lanes have property defined by itsy-bitsy lines, not curves, because the data structures can only define space within lines. As a result, true definition of land surveying precision and accurate areas are sacrificed. Even if the positional geometry were to be correct, to convert this data back to actual property definition would be a monumental task. When we download topographic data from a city, it's likely to be accurate enough for design work. However, with LiDAR, instead of defining a 200-acre site with a few hundred on-the-ground points that a land surveyor would collect to accurately create a contour map, the contours generated with LiDAR can contain hundreds of thousands or millions of points. Let me put it to you this way. If you were to pay cash for your $300,000 home, you could show up with 300 $1,000 bills if they still existed, or you could pay with 30 million pennies. To perform engineering calculations, a computer has to decipher the numbers. If the same data could be defined by 1/1000th of the data, it stands to reason engineering calculations would be 1,000 times faster. The big problem comes with 3D representation that slows to a halt when there's too much data. The land developer that hires consultants using this terribly overloaded data pays the price, with higher engineering fees and that are ultimately passed on to the consumer. The future of land development decisions won't be looking at the same 2D plans of the past 2 centuries, but in interactive 3D and virtual reality. Without filtering the excess LiDAR data correctly to a usable form is not possible. Computer technology revolutionized the speed and accuracy of data collected in the field, but the deliverables that the surveyor delivers to their clients are almost identical to the 1920s. In other words, those paying land surveyors cannot see the value they can create if the office technology did much more than getting the same old plan and same information your grandfather's grandfather would expect. Today, surveyors have a choice. Bring the industry to expectations of 2020 and beyond, or suffer with standards of pen and paper days. Land surveying is more important than ever. If only land developers, real estate professionals, architects, planners, municipal staff, and many, if not most, of the civil engineers were not duped into thinking that online data eliminates the need for this very important but unfortunately dying industry.